The universe. How big is it? Picture yourself standing outside on a clear night, looking up at the stars. You are standing on Earth, a rocky ball spinning through space at 1,000 miles an hour. This planet holds everything precious to us. Every laugh, every tear, every empire that has risen and fallen, and every dream that humans have ever had. But here's the problem with your view from the ground. Your brain is lying to you. It evolved to understand distances in meters and kilometers, to hunt, and to travel across plains. It was not designed to comprehend this. Earth is not the stage, it is merely the starting line. What we are about to discover is that the universe is so impossibly large that even our biggest numbers, trillions, quadrillions, start to break down and lose their meaning. We are going to travel, step by step, from your backyard to the very edges of existence itself. And along the way, we have to confront a terrifying reality. To understand the universe, we first have to admit just how tiny we really are. Let's calibrate our sensors with our closest neighbor, the Moon. It sits roughly 240,000 miles away from us. In our minds, the Moon feels close, just a skip away in the night sky. But if you decided to walk to the Moon, and you could somehow walk on a straight path through space for 8 hours every single day, it would take you about 9 years to get there. When the Apollo astronauts made this journey in the 1960s, they looked back and saw something no human eyes had ever witnessed. Earth as a bright blue marble floating in endless black space. All of human history, every person you have ever known, fits on that small sphere. But the Moon is just the front porch. To go further, walking isn't enough. We need to talk about speed. Now let's travel much further out to visit the Sun, the star that gives us life. The Sun sits about 93 million miles away from Earth. Scientists call this distance one astronomical unit. This measurement becomes super important because in space, using miles is like trying to measure the distance across a continent using inches. Here is a wild fact that changes how you perceive reality. Sunlight takes about 8 minutes and 20 seconds to travel from the Sun to your eyes. That means when you look at the Sun, and please don't actually stare at it, you are not seeing it as it is right now. You are seeing a ghost. You are seeing the Sun as it was 8 minutes ago. If the Sun were to suddenly vanish this instant, we wouldn't know. We wouldn't see the darkness, and we wouldn't feel the loss of gravity for over 8 minutes. We are prisoners of time lag. If you could somehow drive your car to the Sun at highway speeds, the trip would take you over 100 years of non-stop driving. The Sun itself is absolutely massive, about 109 times wider than Earth. You could fit more than 1 million Earths inside the Sun, and it would still have room left over. But as we leave the warmth of our star, the distances begin to stretch exponentially. Our next destination is Mars, the red planet that has captured human imagination for centuries. Mars orbits the Sun at a different speed than Earth, so the distance is constantly changing. When Mars is closest, it's about 35 million miles away. When it's furthest, that distance jumps to a staggering 250 million miles. The robots we have sent to Mars, those amazing rovers, had to travel for 6 to 9 months through the cold vacuum to reach it. As we continue outward, we pass the asteroid belt and encounter the giants. Jupiter, the largest planet in our solar system, sits 484 million miles from the Sun. Jupiter is so massive that all the other planets could fit inside it with room to spare. But even Jupiter is considered close compared to what lies at the edge. Way out at the boundary of our solar system, we find Neptune, sitting nearly 3 billion miles from the Sun. At that distance, sunlight takes over 4 hours to make the journey. If you lived on Neptune, the Sun would look like just another bright star in the sky, offering almost no heat. But the solar system doesn't end at the last planet. It ends where our influence dies. In 1977, NASA launched 2 incredible spacecraft called Voyager 1 and Voyager 2. These robotic explorers were designed to visit the outer planets and then keep going, heading out into the deep unknown. Voyager 1 is now the furthest human-made object from Earth. traveling for nearly half a century and covering over 15 billion miles. Here's something that defies intuition. Voyager 1 is traveling at 38,000 miles per hour. That is faster than a bullet. And yet, despite traveling at that speed for 45 years, it has technically only just left our solar system. It is now in interstellar space, the dark ocean between the stars. From Voyager's vantage point, Earth appears as a tiny speck of light, smaller than a pixel, a pale blue dot. That image reminds us that our entire world, with all its wars, its borders, and its complexity, is just a grain of sand in the cosmic desert. And this is where the human mind usually snaps. Once we leave our solar system behind, distances become almost impossible to imagine. The nearest star to our sun is a system called Alpha Centauri, located about 25 trillion miles away. That number is so large it is useless to us. So, astronomers had to invent a new unit of measurement, the light year. A light year is the distance light travels in 1 year, which equals about 6 trillion miles. Alpha Centauri is 4.3 light years away. Let that sink in. If we put you on the fastest spacecraft humans have ever built, it would still take you over 70,000 years to reach our nearest neighbor. If we could achieve 10% of the speed of light, a technological miracle far beyond what we can do today, it would still take 43 years just to knock on their door. And that is just the house next door. Because we live in a massive city. All the stars you see in the night sky, including our sun and Alpha Centauri, are part of one enormous collection called the Milky Way Galaxy. This galaxy is shaped like a giant pinwheel with spiral arms rotating around a central hub. The Milky Way contains somewhere between 100 and 400 billion stars. That is more stars in our galaxy alone than there are grains of sand on all the beaches on Earth. The galaxy stretches about 100,000 light years from one side to the other. Our solar system sits about halfway out from the center, in a quiet suburb called the Orion Arm. Here is something that really puts our loneliness in perspective. For the past 100 years, humans have been sending radio and television signals out into space. These signals form a bubble around Earth that is now about 200 light years across. But remember, our galaxy is 100,000 light years across. If you looked at a map of the entire Milky Way, our radio bubble, the entire footprint of humanity, would be a dot so small you could barely see it. To 99.9% of the galaxy, humanity is completely invisible and unknown. We are a ghost. But the structure does not stop there. The Milky Way doesn't exist alone in space. It is part of a small cluster of galaxies called the Local Group, which contains about 80 galaxies spread across roughly 10 million light-years of space. The biggest galaxy in our Local Group is Andromeda, a titan containing 1 trillion stars. And yes, Andromeda is actually heading towards us. Gravity is pulling our two galaxies together at 250,000 miles per hour. But don't worry. They won't collide for another 4.5 billion years. And when they do merge, space is so empty that it is unlikely any two stars will actually hit each other. They will simply pass through one another, creating a spectacular light show for whatever life forms are watching. But if we zoom out again, the Local Group is just one small neighborhood in an even larger structure called the Virgo Cluster, which contains over 2,000 galaxies. And the Virgo Cluster is itself just a tiny appendage of an even larger structure. In recent years, astronomers discovered that our supercluster belongs to something called Laniakea. Laniakea means immeasurable heaven in Hawaiian. This structure is a web of 100,000 galaxies spread across 520 million light years. But here is the mystery that keeps astronomers up at night. All of these galaxies, including us, are moving. We are flowing like a cosmic river toward a mysterious region called the Great Attractor. This is a concentrated point of mass and gravity so powerful it is pulling entire galaxy clusters toward itself. We are being dragged across the universe toward a destination we cannot clearly see, obscured by the dust of our own galaxy. And finally, we zoom out to the largest scale possible. We reach the boundary of the observable universe. This is the sphere of space from which light has had time to reach us since the Big Bang. This observable universe has a diameter of about 93 billion light years. Now, you might encounter a cognitive loop here. You might ask, if the universe is only 13.8 billion years old, how can it be 93 billion light years wide? Shouldn't the limit be 13.8 billion? The answer lies in the fabric of space itself. Space has been expanding since the Big Bang. While that light was traveling toward us for billions of years, the space between us and the source was stretching. The objects that emitted that light are now much, much further away than when they started. Within this observable sphere, astronomers estimate there are at least 2 trillion galaxies, each containing billions or trillions of stars. The total number of stars in the observable universe is probably around a 10, followed by 24 zeros. But here's the most haunting part of our journey. The observable universe is just what we can see. It is defined by the speed of light and the age of the universe. Beyond that boundary, the universe likely continues. There could be vast regions of space beyond what we can see. Regions that are expanding away from us so fast that their light will never, ever reach us. They are lost to us forever, severed by the expansion of space. Some scientists think the universe might be infinite, stretching forever in all directions with no end. Others believe it might be finite but still imaginably large, perhaps millions of times bigger than what we can observe. As we complete this mind-bending journey from Earth to the edge of the known universe, we are left with a profound realization about our place in existence. We began on a small rocky planet, orbiting an ordinary star in the outer regions of a typical galaxy. We discovered that this galaxy is part of increasingly larger structures, each one dwarfing everything contained within it. The universe reveals itself to be almost incomprehensibly vast, filled with wonders beyond our imagination. It is easy to look at this scale and feel insignificant, to feel like a mistake of chemistry on a meaningless rock. But there is another way to look at it. Consider this. In a universe of dead rock, violent gas, and freezing vacuums, matter somehow organized itself. It woke up. It learned to feel, to love, and to build telescopes. We are the universe trying to understand itself. We are tiny specks of consciousness in an infinite sea of space and time. We are the only known place in this infinite expanse where the cosmos can reflect on its own beauty. Every time we build better telescopes and develop new ways of studying the cosmos, we discover that reality is even stranger and more magnificent than we dared to imagine. We live in an age of unprecedented discovery, where we are just beginning to grasp the true scale of everything that exists. In the end, our journey through the universe teaches us humility and wonder in equal measure. We are incredibly small. The fact that we can look up at all and comprehend what we see makes us incredibly special. We are the conscious eyes of the cosmos, and our adventure has only just begun.